So question number 6, it says, part A, write down the values of k for which the line y is equal to k is a tangent to the curve y is equal to 4 sine of x plus 5 by 4, brackets close, and plus 10. Okay, so we have to find values of k. So this is k, and this line should be a tangent to this curve. So for any curve, if we are given a curve, we have to first of all find out the derivative of that curve. And the derivative of any curve is a tangent to that curve. So first of all, we have y is equal to 4 sine of x plus 5 by 4 plus 10. So we take the derivative, that comes out dy by dx. It becomes equal to 4 cos of x 5 by 4 plus the derivative of inside, that is x multiplied by 1 plus derivative of 10 is 0. So now what we get, the derivative of this becomes equal to 4 cosine of x plus 5 by 4. This is the derivative. The second step is put dy or the derivative dx equals to 0. So if we put dy by dx equals to 0, this comes out to be 4 of cos x plus 5 by 4 is equal to 0. So this is, this for here, basically, we have to find out for what values of x this whole function will be 0. So before going or before solving it, what we will be doing, so we have to find out the values of k, where this line y is equal to k is tangent. So we have not only the equation of the tangent, we also have a line that is tangent, and these two are actually intersecting. And these 2 points or these 2 lines, and this is one line and this is y is equal to k line, these 2 lines will intersect at this point, and that is that can be taken as cos x plus pi by 4. And if we say, if we are going to make a cosine function looks something like this. This is a cosine function. This is 2 pi, this is pi, and this is 0 here, and this is 0. Any cosine function is 0 at pi by 2 and this 3 pi by 2. So this cos of x is equal to 0, and it means that it will be 0 at x equals to pi by 2, or the value of cos of this function will be 0 at x equals to pi by 2 and 3 pi by 2. So this whole function, I will not say it x, I will call it as the whole function. This whole function will be 0 at these 2 values. So what we get, so the value of x, so okay, so will be cos of x plus pi by 4 will be equal to or we can the easy way for solving it, it will be like this. So this is a cos of theta is equal to 0, and this theta will be equal to pi by 2 and 3 pi by 2. And let's say this theta is replaced by x plus pi by 4. If we replace x plus pi by 4, and this is equal to 0. So the first case, x plus pi by 4 equal to 0 is at this. This is my first case, and this becomes my second case, 3 pi by 2. So from here, I get x is equal to pi by 4. And from here, I get x equals to 5 pi by 4. So these are the two values of x for which my derivative for which dy by dx will be equal to 0. Now what is happening that you have to find the value of k. So this line is intersecting with these two lines, or say this curve is intersecting with this curve. So if the both curves are intersecting, the point of intersection, say first of all, for x equals to pi by 4. For first value, we have k is equal to 4 sine of x plus pi by 4 plus 10. So if we are going to solve this, this comes out to be, or k is equal to 4 sine pi by 2. Put value x equals to pi by 4 here, pi by 2 plus 10. And this gives us the value k is equal to 40. This is our first value of k. And similarly, for x equals to 5 pi by 4, for x equals to 5 pi by 4, we will get k is equal to 4 sine of x plus pi by 4 plus 10. So this gives me, if we put x equals to 5 pi by 4 here, this gives me k is equal to 6. Okay, so write down the values of k. The values of k are plus 6 and plus 40. This is my answer. Okay, so moving ahead, part B, it says show that 1 plus tan theta over 1 minus cos theta plus 1 minus tan theta over 1 plus cos theta is equal to 2 multiplied by 1 plus sine theta divided by sine square theta. So let's take this as left hand side is equal to right hand side. We have to show that. So let's take left hand side. So let's take left hand side. So let's take left hand side. We get 1 plus tangent theta over 1 minus cos of theta plus 1 minus tangent theta over 1 plus cos of theta. So remember, tangent of theta is equal to sine of theta divided by cos of theta. So let's put it this way. This comes out to 1 plus sine of theta divided by cosine of theta whole divided by 1 minus cosine of theta plus 1 minus sine of theta or 1 plus cosine of theta divided by 1 plus cos of theta. Okay, so now simplifying it further, we get cos of theta plus sine of theta divided by cos of theta, and this multiplies with it 1 minus cos of theta. Yes, then we get cos of theta minus sine of theta divided by cosine of theta 1 plus cos of theta. Okay, so this is what we get. Now, further simplifying it, which we get this line, we get cos of theta 1 minus cos of theta into 1 plus cos of theta. This is the LCM. And what becomes 1 plus cos of theta multiplied by sine theta plus cos theta plus 1 minus cos of theta multiplied by cos theta minus sine of theta. Okay, so if we simplify this, this comes out to be something like this. So if we further simplify it and we multiply all the products, what we get 1 sine of theta plus cos of theta plus sine theta cos theta minus cos square theta. Okay, this is our first term plus cos theta minus sin theta minus cos square theta plus sin theta cos of theta and whole divided by cos of theta and 1 minus cos square theta. Okay, cos plus this and this becomes this. So moving ahead, this comes out to be sin theta cos theta. This sin theta cancels with this. So we have this is plus cos square theta. So this cos square theta cancels out with this. So what we are left with, so we are left with 2 cos of theta, 2 cosine of theta plus 2 sine theta cos of theta divided by cos of theta 1 minus cos square theta. Okay. So if we take cos of 2 cos theta common, we get 1 plus sine theta and we get cos square theta. And remember, from the identities given, cos square theta plus sine square theta is equal to 1. So this means that 1 minus cos square theta is equal to sine square theta. This cos theta cancels with this. So what we are left, 2 into 1 plus sine of theta divided by sine square theta. And this is equal to right hand side. And answer we have shown. Okay. This is as simple as that. So moving ahead in say part 2, since so hence solve the equation. So it is the same equation as earlier, and this is equal to 3 for 0 less than equal to theta less than equal to t. So we have shown that this whole right hand term is 1 plus tangent of theta plus 1 minus cos of theta plus 1 minus tan theta or 1 plus cos of theta is equal to 2 into 1 plus sine theta over sine square theta is equal to 3. So we have shown this. So what it comes out to be, it becomes 2 into 1 plus sine theta is equal to 3 sine square of theta. So this becomes equal to this. So now if we are going to solve this part, this will give us the answer for theta. So I'm basically solving this. So let's solve this. So it becomes this. So let x is be equal to sine of theta. So if my x is equal to sine theta, it would be 2x. So it will be 2 plus 2x equals to 3x square. So this is a quadratic equation. 3x square minus 2x minus 2 equals to 0. So if I'm going to solve it, I will be getting x1 is equal to 1.215 and x2 or the roots of this quadratic equation minus 0.48. Okay, so this and you can remember you can solve it by x equals to minus b plus minus under root b square minus 4ac over 2a. So you'll have two values where value of a is 3, b is minus 2, c is minus 2. If you put in these values in this equation, you will get these two values. So now I have two values of x. So replacing x, replace x by sine of theta. We get sine of theta is equal to 1.215 and we get sine of theta also equal to minus 0.548. So this value is rejected since because as sine theta is less than equal to 1, or 0 less than equal sine theta is equal to 1. The value of sine of theta should never be go more than 1 when theta is in degrees. So similarly, we have given as the sine theta. Right? So this value is what we'll be using to find out the value of theta. So remember the four quadrants, all positive, cosine positive, tangent positive, sine positive. So our angle, since this is a negative value, our angles will lie in quadrants where our theta is negative. So it means that it will lie in here, it will lie here. So these are the positive values. So we do not have values in upper quadrant. Would be the two angles will be lying somewhere here. So what we'll do, we'll calculate. So theta is equal to sine inverse of 0 minus 0.548 degrees. So theta becomes equals to minus 33.2 degrees and theta equals to minus 146.8 degrees. Okay, so these are the values of theta. So it means that it is going something like this. So this is one angle. This is minus 33.2. And similarly, this angle. This angle is minus 146.8. So, and we can also, if you're going counterclockwise, these angles will be, this angle will be, or you can call it as 213.2 degrees, or you can call it as 326.77 degrees. So any of these two you can use for your answers. So either use these two values or these two values for your answers, and both will provide you the correct answers. Okay. So moving ahead, question number 7, it says that the first three terms of an arithmetic progression are log 3, 3 log 3, 5 log 3. So remember, this is an AP or arithmetic progression. Sum of the, given that the sum of the sum to the n terms of the progression can be written as 25 log of 81, find the value of n. Okay. So find the value of n. So for any progression, remember sum to n terms is given as n by 2 uh, brackets 2a plus n minus 1 into b. So in this term, your a, the first term value is log of 3. The sum to n terms s of n is given as 256 log of 81, and difference is so the difference between two terms is 3 log of 3 minus log of 3. This comes out to be 2, or we call it log of 3. This is difference. Okay, so b is this. Now putting in the values here, what we get 256 log of 3 log of 81. So multiply by 2 is equal to n 2 times a, 2 into log of 3 plus n minus 1 into d is 2 log of 3. Simplifying it, what we get um, so simplifying it, we get 256 into 2, 512 log of 81. So remember, 81 is 3 log of 3 power 4. This is 2n log of 3 plus n square, 2n square log of 3 minus 2n log of 3. So this 2n cancels out with each other. This 4 goes and multiplies over there. So this comes out to be 12048 natural. So log of 3, we get 2n square log of 3. So it comes out to be 1024 log of 3 is equal to n square log of 3. So what we left, so we have n square is equal to 1024. So n is equal to plus minus 32. Fine. So a number of n terms, so n is equal to 32. That is our answer. So number of terms will always be positive. So this is what our answer will look like. Okay. So next part B, it says, again, you don't have to use a calculator in this part of the question, so be careful. It says the first three terms of a geometric progression. So remember, it's a geometric progression, and geometric progression will be AR square, AR cube, and so on. So the first three terms, A is ln256, AR is ln16, AR square is ln4. Okay. Sine sum to infinity. So we have to find the sum to infinity. And remember, sum to infinity is equal to A divided by 1 minus R. So for if we have to find R is equal to AR divided by A. This is natural log 256 divided by natural log 16. So this comes out to be 1 by 2. Oh, sorry, I have put the value. This is natural log 16, and this is natural log 256. Answers comes out to be 1 by 2. Okay. This comes out to be 2. Now put this value here along with the value of A. So sum to infinity will become natural log 256 divided by 1 minus 1 by 2. So this comes out to be 2 natural log 256. This is our answer. Okay. 2 natural log 256. And again, we have to find, oh, sorry. We have to use this format. So P natural log of 2. This comes out to be 2 natural log P, and P is 2 raised to power 16 to the power 8. Yes, 2 raised to power 8. Oh, sorry. So this is natural log 2 raised to power 8. And if I simplify it, it becomes 16 natural log of 2. And this becomes equal to P ln of 2. If you compare, so P is equal to 16. And in this form, this is the sum to infinity. This is our exact answer. Okay, so remember, this is not the answer. We are not going to call it as answer. This thing is should be written as this to qualify it as an answer. So moving ahead, question number 8, it says find the exact coordinates of the points of intersection for the curve. So we are given a curve and a line. Again, we're not supposed to write. So remember, use calculators. So we have to simultaneously solve these equations. Okay, we have to simultaneously solve these equations. So we have given as y is equal to x square plus 2 under root 5 x minus 20. This is my one equation. And y is equal to 3 under root 5 x plus 10 is equal to y is becomes equal to s. So solving this question in a easier manner, let's say, let you can say under root 5 into x is equal to a. Okay, and x square will be then equal to a by under root 5. Okay, so change the equations. Y becomes equal to a by under root 5 plus 2 mm, Okay, so a by under root 5. So no, x square will be a square by 5, not under root by 5. So this will become a square by 5 plus 2a minus 20. This becomes, let's call it equation 3, and my below equation becomes 3 into a plus 10. This becomes equal to 4. Okay, so now simultaneously solving 4, we becomes 3a plus 10 equals to a square by 5 plus 2a minus 20. So we are left, if we simplify this, what we are left is with a square minus 5a minus 50 is equal to 0. So this is the equation what we get after solving this. So now, so a is equal to minus b. Remember a1, a2 plus minus under root b square minus 4ac over 2a. So use this to solve this quadratic equation. Okay, so solve this quadratic equation. We get a1 is equal to 15 and we get a2 is equal to minus 10. So now we have the values of a1 and a2. So remember, uh, x was equal to a by under root 5. So we get x1 is equal to 15 by under root 5, and similarly x2 will be equal to 10 by under root 5. So these are two values of x1 and x2, and we have to find y. So for x equals to 5 and y is equal to, uh, just put in the value of y will become uh, 3 under root 5 multiplied by 15 over under root 5 plus a 10. So this cancels 45, that becomes equal to 55. And similarly for x equals to minus 10 by under root 5, the value of y will become equal to minus 20. Okay, so the coordinates, remember, coordinates are 15 under root 5 and 55, and minus 10 under root 5 comma minus 20. These are the coordinates. You can call it as answer. Okay, so moving ahead, part B. Part B, it says it is given that tangent of theta is equal to under root 3 minus 1 over 2 plus under root 3 for 0 less than equal theta less than equal to 90 degree. Find cosecant square theta from the value in the form of this. So remember, you are given the trigonometric formulas. So we know that cosecant square theta is equal to 1 plus cot square theta, where cot of theta is equal to 1 by tangent of theta. Okay, so 1 by tangent of theta, this is, we can find out that cot square theta is 1 over tangent square theta. So let's find tangent of square of theta. So tangent square of theta is under root 3 minus 1 over 2 plus under root 3 whole square. So if we do the whole square, this becomes tangent of theta, and putting it in this formula, cosecant square theta, we have to find out the value. It becomes 1 plus 1 over tangent under root 3 minus 1 whole square divided by 2 plus under root 3 whole square. Okay, so this is what we will get. And if you're going to simplify and solve it, this becomes 1 plus 7 plus 4 under root 3 over 4 minus 2 under root 3. And further, if we further simplify it, it becomes cosecant square theta as 11 plus 2 under root 3 over 4 minus 2 under root 3. Okay, so find cosecant theta in terms of this and compare it in with the form a plus b under root 3. So we have to basically convert it into this form. So converting it into this form, it comes out to be 11 plus 2 under root 3 over 4 minus 2 under root 3. So multiply and divide by 4 plus 2 under root 3. 4 plus 2 under root 3. And multiply and divide by this becomes equal to 14 plus 15 by 2 under root of 3. And this value is equal to cosecant square theta. Okay. And this value is equal to a plus b under root 3. So a is equal to 14 and b is equal to 15 by 2. Okay. And this is our answer for this question. So moving ahead, next question or the second last question for this exam, question number 9, it says a circle with the center 0 and radius r has a sector OAB of fixed area 10 centimeter square, angle AOB in theta is theta in radians. So this is theta in radians, and the parameter of the sector is P. Find an expression of P in terms of R. So say we have this circle. This is the center of the circle. This is O. This is A, B, A, O, A, B. This is our required sector. The angle suspended is this, and the perimeter of the circle. So perimeter is this plus this plus this. So perimeter is equal to R plus arc length AB plus another radius R. And remember arc length is equal to S equals to R of theta. So the perimeter becomes 2R plus R theta. This becomes the perimeter of the circle. S equals to R theta, and perimeter in terms of R only. So also remember area is equal to A equal to half R square theta. Area is half R square theta. So area is what we have like this. And the A value of area is 10 centimeter square multiplied by 2 over R square is equal to theta, which means theta is equal to 20 by R square. So put this value of 20 by R square over here. So we get P equals to 2R plus 20 over R. Okay. So this is the equation or expression of P in terms of R. 2R plus 20 over. Then says find the value of R for which P has a stationary value. First of all, remember P is equal to 2R plus 20 by R. For stationary value, the first derivative must be equal to 0. Okay. So the first derivative will be equal to 0. So dP by dr becomes 2. This becomes minus 20 by R square. Okay. And putting it equal to 0 is this. Now R2 R square minus 20 is equal to 0. This is to mean that R is equal to plus minus under root 10. And this, since this is radius, this is in centimeters. So the which find the value of r for which p is stationary. So remember, if I put r equals to minus under root 10, so minus under root 10, it will be, let's try to calculate it. The calculation. So minus and under root 10 is 3.162 multiplied by minus 2 plus. So if I put, say, if I use, so r is equal to minus under root 10 centimeters. So this is not possible. Radius cannot be negative. So we will be rejected. So the r value is only under root 10 centimeter. So we are not going to use the negative value for this. Then part C, it says determine the nature of the stationary value. So remember the nature of the stationary value. So for the nature of the stationary value, we need to find out the second derivative. Okay. So second derivative again, so we have to do dr of 2 minus 20 by r square. So we calculate it becomes equal to 0 minus 60 by r cube. So this, so the value is for all values of r, or you can call it as for all values of r, the the, the second derivative is less than 0. Okay. No, it becomes point. So it is greater than 0. Second derivative becomes greater than 0. Positive. The value corresponds to a minimum value. So this will be a minima or a minimum value of the function. Then part D, it says find the value of theta at the stationary value. So remember, we have area is given as half r square theta. Area was equal to 10, 1 by 2. R square, this value is 10 square, and we have to find out the value of theta. So 20 divided by 10 is equal to theta. This becomes equal to 2 radians. And this is our answer. Okay. So moving ahead, the last part of this question, it says question number 10, it says the normal to the curve. So we are given a curve. This at point P with coordinates. Say, for example, this is a curve. This is the point P and normal to the curve. So draw a tangent and this is say normal to the curve. So at point P with coordinates, this is P comma minus 1, where 0 P is 0 less than P less than this, okay, meets the x-axis at point A. So this is normal line. Okay, so normal line, and it is meeting at, say, this is the x-axis at point A. And B axis point A and cuts the y-axis. So imagine this is the y-axis and this cuts at B. Find the exact coordinates of the midpoint of AB. So we have to find, first of all, find coordinates of A, then B, and then we have to find out the value of A and B. Okay. So first of all, what we do? So point P lies on the curve. Remember, point P lies on the curve. So if you put P minus 1, it means that it should be satisfying y is equal to tangent of 3x plus pi by 2. Okay. So if I put y equals to minus 1 for y equals to minus 1, value of x will be equal to p. So this will give me the value of x. So put it here. We get -1 tangent of 3x plus pi by 2. Solving it, we get x is equal to minus 45 degree and x equal to minus 225 degrees. Okay, or we get x equals to 135 degrees and 315 degrees respect. Okay, so these are the values of x which one will be there. Okay, so my point B will be this. And since this point A, uh, okay, so again, P, remember, so P, so X is equal to P, and this is the value given. So we are also 0 less than equal X less than equal pi by 6. So pi by 6 is equal to 180 divided by 6, and this is equal to uh, 30 degrees. Okay. So the value of X must be in this domain. So this is, I will not call it x, it call it theta. So these are the two values for which the tangent is -1. So the tangent is -1 for these three values. It means that for theta is equal to 135 degrees. For theta equals to 135, we get uh, 3x plus 90 degrees equal to 135, and x is equal to 15 degrees. And similarly, for theta equals to 315 degrees, we have 3x plus 90 degrees is equal to 315 degrees. So x is equal to 100 and so x is equal to 75 degrees. So theta, so this value is less than 30 degrees. So this is fine. This is greater than 30 degrees. This is not allowed. So x, value of x, which is equal to P, is equal to 15 degrees. And 15 degrees is can be because 180 divided. This is also written as pi by 12. Okay. So the value of P or point P will be P comma -1. And this value is pi by 12 comma -1. Okay. So again, it says find the coordinates of the midpoint of A and B. So there is a curve, and at the point P at the curve, we have calculated the value of P correctly. What it says, is the x-axis at point A, and this point is the normal to the curve. So normal to the curve, okay. So slope of the curve. Okay. So slope of the curve. So for the slope of the curve, we have to first take the derivative. So dy by dx of the curve. So dy by dx of the curve. So let me write this in a separate color so it becomes more easier to understand. So slope of the curve. The slope of the curve. So dy by dx. This becomes equal to derivative of tangent of 3x plus pi by 2. So derivative of tangent is secant square 3x plus pi by 2 multiply by the derivative of whatever it's inside, multiply by derivative of 3x, that becomes equal to 3. So the slope or dy by dx becomes equal to 3 secant square 3x plus pi by 2. So this is the derivative, so it's the slope, and dy by dx at point P is equal to, which is pi by 12 comma minus 1. So put in the values, x equals to pi by 2, so 3 secant square 3 into pi by 12 plus pi by 2. So if you put in the values and do the square, this value comes out to be 6. So the derivative of the slope or the slope of the tangent is 6. So slope of normal line, this will be equal to m tangent multiplied by m normal is equal to minus 1. So m tangent is 6. So m normal is equal to minus 1 by 6. So this is how slope of the normal line comes. So slope of normal line, this is mn, and this comes out to be minus 1 by 6. So consider a diagram like this. We have a curve like this. This is, or um, much easier. Say you have a curve like this. This is your point P. This is the tangent over here, and this is the normal line that is going. This is your x and y axis. So this is your x. This is your x-axis, assume, and so this is your y-axis. So this is your y-axis. This is x-axis. This is point A. This is point B. Okay. So we have found out the slope of the normal line. So this is your normal line. So we have the slope and a point on line is P, and that is pi by 12 comma minus 1. So we have a point in the slope. So equation of normal line can be found out by y minus y1 equals to m into x minus x1. Okay, so y minus y1, the point, this is our y1, so plus 1, slope minus 1 by 6, x minus the x1 is pi by 12. Equation of the line is y is equal to minus x by 6 minus 12 into 6 plus pi by 72 minus 1, 1 by 72 minus 1. So it comes out to be y is equal to minus x by 6 plus this minus, so this minus 71 by okay, no, is again y by 72 minus 1. Okay, so this is, I'll keep it as, so this is my equation of line. So at point A, remember at A, I mean, it is, we have x-axis. So at x-axis, we have y is equal to 0. So coordinates of A will be y is equal to 0 minus x by 6 plus pi by 72 minus 1. So this turns out to be okay. So this turns out to be minus pi by 72 plus 1 is equal to x multiplied by 6. So this comes out to be minus pi by 12 plus 6, or 6 minus pi by 12. This is one value. Okay. So my A point is 72 minus pi divided by 6, comma 0. This is my point A. Okay. This is my point A. And similarly for point B, so point B would be, is it right or is it wrong? Let me cross check first. So it's minus, I put it over here. So x, putting y equals to 0, uh, 6, 6, let me say it here, 6 plus 6 minus pi by 12 minus 6 plus pi by 12 minus 6 plus pi by 12. So minus 6 plus pi by 12. So it means that this value will be let's do it again. I'm a little confused. So for y is equal to 0, okay, equation of tangent, I will use it as such. I will not simplify it. I will use this as the equation of tangent. It will be more easier to handle this. Okay. So this. So at point A, we have y is equal to 0. Since it is an x-axis, we are good. So y plus 1 is equal to minus 1 by 6, x minus pi by 12. This is what we get. So x will be equal to what? So this comes out to be minus 6 is equal to x minus pi by 12. This turns out to be x is equal to pi by 12 minus 6. So x is equal to pi by 12 minus 6. Okay. Is this the right answer? So minus 6 pi by 12, perfectly fine. So x is pi by 12 minus 6. So this is my point A. Similarly, let's say at B, at point B, we have the y-axis. We have the y-axis. It means that x is equal to 0. So at B, we have y plus 1 is equal to minus 1 by 6, 0 minus pi by 12. Okay. So this turns out to be y is equal to pi by 72 minus 1. Yes. So point B will be x is equal to 0, pi by 72 minus 1. So now I have two values. So I have 2 points, A and B. So now I have to find midpoint of AB. Midpoint of AB is x1 plus x2 over 2. Similarly, y1 plus y2 over 2. So the midpoint of this will be x 5 by 6 by 6 multiplied by 12 divided by 12 multiplied by 2. This is A, and this will be 5 minus 72 over 72 multiplied by 2. So this will be the value of midpoint. So pi minus 772 divided by 24.1, and pi minus 72 over 144. This is midpoint, and this is my answer. Okay, so this is how you'll be able to find the value of midpoints. Pi by 24 minus 3, or if you simplify it, I will write it. I'm writing it in red. You can also call it as pi by 24 minus 3. This is 0.1. Pi by 144 minus 1 by 2. Okay, so this is another value, and this value is actually what is written in your marking scheme. So that's how also you can go. So again, thank you very much for listening. This is how we solve this question. And again, I wish you all the best for your preparation of the exams. Take care.